Hello everyone. So welcome to the Discrete Mathematical Structure Module-2 Session 6. Fine. So in the previous session, Session 5, I just made you to be introduced or just to know about a small flavor of what a combination is going to be and what a permutation is going to be. Fine. So that was all about what we learned, the sum rule and a product rule, and exactly in what given scenario and in what given situation or in what given problem you need to analyze and evidently say whether you need to use a sum rule or you need to use a product rule, or at certain time, as I mentioned in the last example what I discussed, it's both with the sum rule as well as a product rule. So now it's the right time for me, as I think, to introduce you the next important concept, or the important concept which we are about to dive into, that is the permutation. And the word what I'm saying, it is not new to you, but still let me put the way I know and to make sure you understand the permutation concepts in a better way. Fine. So let us start what is permutation is going to be. So we'll discuss what is permutation. And later, once you are aware of what is permutation is or how to deal the permutation, let us take up combination. Until that, we will not discuss much about combination, but here and there I will be using the word as combination, but it doesn't mean that I am referring to the concept of combination. Fine. So in that term, first let us look into this permutation in detail with few examples, and later we'll jump into the combination concept. Fine. So now when I'm going to talk about a permutation, what is this permutation is going to be all about? And how do I define this? Though the definition is not going to be in the exact words, but let me tell you. So now you have been given n objects. You have got n objects. So these objects can be anything. So I'm just going to call this as n objects. And so rather than saying this as n objects, specifically you need to make sure it is going to be a distinct object. It should be a distinct object. Hence n object, so which are distinct. And what does this distinct say? It's an independent object which is not dependent upon. That is, now if I am going to take, there are 10 books, each book is an object and each book is a distinct object. If I pick one book, the other 9 books stays as it is. There is no dependency. Fine. So that is where we say the distinct object is going to be all about. Fine. So now we are going to have n distinct objects to be specific about. Out of this n distinct objects, I need to choose. So choose R objects for arrangements. So what does I mean? Fine. So that means I'm just going to take this n objects. Out of this n objects, I will be taking R objects and I am going to put them in some sort of arrangement. The arrangement is going to be in any form, in any order. I am not going to decide what order right now it's going to be, but in any order. When I say any order, when a certain situation is given, unless the condition is not specified, you need to make sure you will produce or you will present all the possible orders. That is what permutation is going to be. So what does permutation say? I'll just put in the other words. I've got n objects. This n objects, out of this n objects, I need to choose R objects. That is, I've got 10 books. Out of those 10 books, I'm going to pick 5 books. Choose the 5 books. Out of this 10, any 5 books I'm going to pick. So the 5 books which have been picked, I can arrange in any order. That is, I'm going to pick book 1, book 2, book 3, book 4, book 5. One arrangement. Book 2, book 1, 3, 4, 5. The second arrangement. So on you can put into any sort of combination. So right now when I say combination, again, don't go into the actual concept of combination. This is just a general word what I am using right now. Fine. So when I say permutation, pick the R objects from the given lot and say how many arrangements you can make. That is what the permutation is going to tell you, or the permutation is going to ask you about. Fine. So now I'm just going to give an example and show exactly how the permutation happens and how do we derive an general form of permutation in form of an expression or in form of a formula, so that we can solve any given permutation problem. Fine. So in that regard, now just take the words. It has A, B, and C. Now there are three alphabets. Now just look into this as three independent alphabets or independent characters. A is object 1, B is object 2, C is object 3. So now out of these three objects, I am just going to pick two objects. Hence, I am just going to pick two objects. So now what is the value of n? N is going to be 3, because in total, in the given lot, in the given option, there are three objects. Hence, I am saying n is 3. And out of this given n objects, I need to pick two objects. Now, how you can go with this? So now, I am going to have A, B, C. I am going to pick two objects out of this. Hence, I am just going to pick A, B. I am just going to pick A, B. And next, I am going to pick B and C. I am going to pick B and C. And I am going to pick A and C. This is one set. But as I told you, I need to find all the possible arrangements. Remember this. And for that reason, along with AB, so BA also will be part of this, CB and CA. These are the possible ways for the given n objects and the number of objects what I want to pick. This is going to be the number of ways, and this is what I need to find in permutation. Fine, I hope I am clear with this, what the permutation is going to be. So now let me derive a general theory out of this. Fine. So now whenever I am going to have n objects, right? So just observe in this case, when I am going to have n objects, fine, at this point. So if I want to pick the first object, that is out of this, now I need to choose two objects. Fine, then it will be as it is. I want to pick one object from this. How many options you have got? You have got three options. Now what is the value of n? It is 3. Can I say this as n options? I got n options because n is 3. So now once I have choose the first object, I will be left out with how many objects? 2 objects. That means I can say this as n minus 1. I am going to have n minus 1 object. So now if I am going to pick one more object, what I am going to left out with? I am going to left out with only one more other object. But right now R is 2, hence I need not worry about this, but let me put it over here, n minus 2. Is it fine? So now in general, if I am going to write this, now all this picking first object, I need to pick the second object along with this. I need to pick the third object if I am picking. Right now I am not doing that, but if I am trying to pick this, I need to pick along with this object again. And now for that case, what I am going to do, when I say along keyword, I am going to make use of a product rule. I'm going to make use of a product rule, and this is going to be n into n minus 1 into n minus 2. But now just observe here, I said that there are n objects, I need to choose only R objects, but nowhere in this form I'm dealing with the value R. Fine. So for that, just observe here. I'm just going to have this as n as it is. So now, can I replace this with r? Can I replace this with r? Just think about this. Can I replace this with in the form of r? So hence, I'm just going to say as n minus r plus 1 or n minus r minus 1, because r is 2, hence I'm replacing 1 with r minus 1. R is 2, so 2 minus 1 becomes 1, and this is going to be n minus 1 for me. So this is what I'm going to bring r into picture now. When I do this, I know where exactly I need to stop, because this is what I told you. If r is not in the focus or in discussion, this combination will go until n minus 2. But when the r is given, somewhere I need to choose my option or stop my selection. I have selected 2 objects, you need to stop at that. And how do you stop this? Using the r variable. That is what I am replacing 1 with r minus 1. So hence, in general, if I am going to have n with 4 objects, now the form is going to be n into n minus 1 into n minus r minus 1. Now n into n minus 1, now this is supposed to be n minus 2. Now the value of r becomes, now if I want to choose 3, or let me make this as 3 now. So now r is 3, so 3 minus 1 is 2, hence I am reaching n minus 1 and n minus 2. So this is how in general I am just going to write it out. So now let me put it in general case. This is the specific phase what I am presenting to you. So in general, you will be having so many objects. You will be having n objects, and the value of n will change. As in general, every time I cannot state the form will be in this way or the form will be this way. So in general, where do I stop this at? Fine. So for that case, just look at this equation what I am going to write. For given n objects, and r choice, I need to make r selection. I'll just put this as selection. So now for the given n objects and r selection, so which I'm going to use the form of permutation. Hence, I'm going to denote this as P for permutation, and this permutation depends upon n value as well as r. I'll just write it in the form of npr, or this can be also written as P of n comma r, or this can also be written as P n r. So you can use any of this form, all are same denotation. But in some textbook or some source of information where you're going to fetch, it depends upon what form you go, but all these 3 will remain same. So, but we will be using this form sometimes I'll be using this form. Whenever you use this, so please do not get confused, because both are one and the same. So now I am going to have P of n comma r. This is equivalent to n into n minus 1 into n minus 2 multiplied, I'll just put the multiplication symbol here, multiplied until where? As I have just mentioned, I will reach until n minus of r minus 1. Fine. So this is what I just presented to you, until n minus r minus 1. So now just look at this form. So this is going to work fine for me, but let me simplify this form a step further. Now just look at this. So this is in the form of n factorial, because if I just look at this form, somewhere in my mind it strikes me that this is something looking like n factorial. but something is missing. Something is missing. So now, as you all know, the n factorial will stand as n into n minus 2 into n minus 3, so on until 2 into 1. Fine. So this is n factorial. So something is missing. I have got n, I have got n minus, this should be n minus 1, and this is n minus 2, I have got n minus 1, I have got n minus 2, so on. But I am missing this into 2 into 1. I need to reach until into 2 or into 1. Else, for that case, what I am supposed to do? So now let me multiply this. Let me multiply this, or just to give more clarity about this, let me rewrite this. Let me rewrite this entire expression for you. I'm just rewriting this. So where I am going to have P of n comma r is equivalent to n into n minus 1 into n minus 2 into so on until we have stopped at n minus r minus 1. n minus r minus 1. So if I go further, what's the next element I'm going to get? The next element I'm going to get after this, yeah, this is going to be n minus r. That is the next element, because this is r minus 1, and if I put plus 1, if I increment r by 1, minus 1 and plus 1 will get cancelled. I remain with r. Hence I am going to have n minus r into n minus r plus 1. That is, it will be just keep on going. It will just keep on going, or I'll just put this in this form. Right? It will just keep on going. So I add r minus 1, r plus 1, so on until where this is going to reach, until this is going to be 2 into 1. I am going to have until 2 into 1. Is it fine? Because I started at n. Now somewhere I reached this point, but still I get continued and I stop at 1, because n will be keep on decrementing and will reach 1. This is the reason why I have been put over here. So now I have been multiplied with this component, and right now just observe this component, and now when I add this as a component, I need to divide this entire thing by whatever I have been multiplied. Hence I am going to have n minus r into n minus of r plus 1 into so on until 2 into 1. Fine. So now just look at this. So this is in the form of n minus r factorial. This is in the form of n minus r factorial, because if I say n factorial is n into n minus 1, n minus r factorial is n minus r into n minus r plus 1, so on until 1. Similarly, this is in the form of n factorial, and this is in the form of n minus r factorial. And so this I am going to generalize this as Pn comma r equals n factorial, as the entire thing, divided by n minus r factorial. So this is how exactly we are going to come to the point saying what is the value of permutation is going to be and how the permutation is going to be. And at this point, I hope you have understood how I derived the permutation general form. That is n factorial divided by n minus r factorial. Fine. So upon this, we will just try to build upon the problems. We'll try to solve the problems, and we will just fetch few more properties of this permutation. Right? So to fetch the few more properties of the permutation, now in general, so now at this point we all know what is P of n comma r is, and do remember this. If you don't remember how we have been derived, but you need to remember this form. So n factorial divided by n minus r factorial. Fine. So now in this case, I have got different case where I can present this now. Fine. The very first case is, now this is a general case. Now what if the value of n and r are same? What if n is equivalent to r? That is, I have been given you 5 books and you need to choose 5 books. The n objects, and I need to choose the same r objects. 5 books out of I need to choose all the 5 books. Now in this case, now what is going to be the form? What form it's going to be? So now I am going to have P, n and r is going to be same now. It's going to be same. Hence, now for example, if this is 5, I'll be having 5 factorial divided by n is 5 minus 5, 0 factorial will be 1, as this is going to be n factorial. That is, now whenever, if n equals r, then P of n comma r is equivalent to n factorial. So do remember this. Fine, do remember this equation. So I'm just going to give an example of how exactly this should be made use of. I'll just come to this case in a few minutes. But now, what if the value of r is 1? What if the value of r is 1? That is, if r equals 1. If r equals 1, now what happens? N is as it is, n minus 1. Replace r with 1. So n minus 1 becomes n minus 1 factorial. Fine. And so now, if r is going to be 1, in that case, I'll be having n factorial divided by n minus 1 factorial. Fine. So just I'm going to write this and I'm going to show you. Fine. Now this is going to be equivalent to n factorial divided by n minus 1 factorial, because r value is 1. So now let me just expand this n factorial just by one step. Fine. So what if I expand one step? This becomes n into n minus 1 factorial. Now just observe here what I have just made. N minus 1 factorial is going to cancel this n minus 1 factorial. It gets cancelled and I am going to end with n. And so whenever r is going to be 1, in that case, so P of n comma r is equivalent to n. It's going to be equivalent to n. So this is how we need to look into these two cases. What if n equals r? Directly say it as n factorial. What if r equals 1? You're going to directly say it as n. It's going to be just n always. Because if I say I want to choose one object from the given lot, it is going to be n ways. No arrangement is supposed to be done at this end because I've got only one object every time. And so this is how we're going to make use of. So now, as I told you, I've got case 1. I've just got case 1, where in the case 1, I'm going to have n equals r, and in the case 2, I'm going to have r equals 1. So what's the other case you can think about? The other case what you can think about is, now at any point of time, this n and r value cannot be negative. So don't think about such cases. The only possible value r can start with 1. Even don't say the r can start at 0, because you cannot say in the given n objects choose 0 object. Is it meaningless? So it does have any meaning? So it is going to be meaningless. Hence, so choosing 0 objects from a given lot, it's not a good. Fine. Hence, for that case, we'll start r from 1. Hence, we have addressed this issue, and the r value can reach up to n. R value can be 1, r value can be 2, can be 3, can be 4, anything until the value of n. Now, what if you say the value of r is going to be greater than n? What in certain case when I say r is greater than n? Again think now. there's going to be only 5 books, and now you are saying choose 6 books from the given lot. Again, it's meaningless. Hence, R value even cannot be this point. So at any given point, you need to make sure in the any other case, that is in any other case where the value of R is going to be greater than 1, greater than or equal to 1, or I can say greater than 1, and it is going to be less than n, because for 1 the case 2 will help me out, for n the case 1 will help me out. Only for the remaining cases you should think about this formula. Hence for the case 3 this is the form, for the case 1 just n factorial, for the case 2 this is going to be the n. So this is how you need to think about it. This is fine. So we'll just use this form in a few minutes, but I'm just going to ask, and as I just told you, we'll more discuss about the case 1. This is what I just told you right now. So now, being in the case 1, that is the form where P n comma R equals n factorial, that is I need to choose all the objects. In that case, so now let me take the example of 3 objects A, B and C. I'm talking about this case where the value of n is equivalent to R. That means if n is 3, R is also 3. It is n factorial. Hence, now I am going to have n as 3. So let me put it over here for your clarity. N is 3, and even I want R also to be 3. In this case, I am going to use this form n factorial. So I'll just check out how I got the n factorial. Also, I'm just going to put it answer over here. Now this is going to be 3 factorial, which is 3 into 2 into 1, which will give me 6. That is, there are 6 ways. There are 6 ways of arranging this. And how it has happened? So I'm just going to have ABC. So ABC is the first way, ACB is the second way, BAC, BCA, CAB, CBA. 1, 2, 3, 4, 5, 6. 6 ways. Instead of putting it in a list, use the formula and you have got how many ways you have got. And this formula we are using because if it is only 3, I can easily find it out. What if it is 15 objects? What if it is 100 objects? You cannot write all the patterns and keep on counting. Hence, for that case, you are going to have such a way. So I hope you are clear how did I got this. So now let me give you one more variant upon this. The next variant is, now I am going to have A, B, B. Now just observe here, what difference does it makes? I had A, B, C here, all the objects are distinct as usual, and all the objects are different as well. They are not identical. In this case, just observe here, there are 3 objects, 3 distinct objects, but if you carefully observe, there are identical objects. Still, though they are identical objects, still we call this as distinct. So don't get confused with distinct and identical. Still they are distinct, but they are identical. Now just observe how many ways you can do this in. How many ways you can do this? That is, I am going to have A, B, B is the first way. Second way is A. Again I am going to, so can I have again B, B? It remains the same pattern. It's meaningless. And so I cannot start with A again. But I can start with B and I can say BAB. I can have B and BA. That's it. I don't have any other option. Even if I try to draw any option, it will just be replication of this. Hence I cannot do so. Now just observe here. The n value was 3. Again here the n value is also 3. If I have tried to apply the same formula. If I try to apply this formula, for this I am ending with 6 ways. What you are seeing evidently. Even for this, I should have ended with 6 ways if I use the formula, but evidently I am seeing only 3 ways. What has happened here? This is due to identical objects. And identical objects, if you put in any arrangement, it's still same for us. That's the problem of this particular example. And how to deal with this? I'm just going to show you now. Fine. So now whenever you're going to have such scenarios where n equals r, being in this case, being in the case of n equals r, what exactly I need to do here is, now this p n comma r will be equivalent to n factorial divided by n1 factorial into n2 factorial into so on n k factorial. Now what is all this? See, when I say n1, it is a group of similar objects. n2 is second type of similar objects. n3, the next type of similar objects. So on, you should be able to draw 6 type of objects. Now, for example, I'll just tell you what exactly this is going to be. Now, just look into this example again. In this example, directly I can use this form, but we'll just put into this form and check it out whether I'll end with the same solution or not. So now, A is the first type, B is the second type, and C is the third type. And how many of A's are there, or how many objects of the type A are there? Only one. It is 1, B is also 1, C is also 1. Hence, I am going to have this as 3 factorial divided by n1, the first type object is 1, hence 1 factorial multiplied with 1 factorial multiplied with 1 factorial. Fine. So now 1 into 1 into 1, I again end with 1. 3 factorial is 6. 6 by 1 is 6. I still end with the same. But now where it matters, just look at this now. I have got 3 objects, n equals 3. But now A is of one type. Sorry, the type A object is going to be of only 1. Hence the count is 1. Hence so stay at 1 factorial. But look at B now. The second type has got 2 objects. Hence this should be 2 factorial. This should be 2 factorial. And now just look into this way how this is going to solve my problem. So 3 into 2 into 1, which is 3 factorial, divided by 1 into 1 is 1 factorial, and this is going to be 2 into 1. I will just cancel this 3 and end with 3 ways. Now just look, I am going to have 3 ways only here. So this is how we are going to make use of when you want to pick all the n objects, or at certain time when you are picking R objects also, think about this. Fine. So work on the frequency of the objects. Depending upon the frequency, I am going to use this form. If you find all the objects are not identical, or all are different objects, distinct and different objects, certainly go directly and use n factorial. At some point, if you see any of the object is going to be identical, remember this general form and make use of this. So this is how exactly we are going to make use of the permutation equations. So this is the general equation, and whatever I gave you is just a general form. It's a variation of this. Fine. So now what if R is same as n? I just given you. What if R is 1? I just given you. And what if n and R are same and with identical? What the form I am going to use? So please do remember these forms. This is going to help you out to solve the problems which we are going to discuss in few minutes. Is it fine? So this is what you need to have the basics of permutation before you start applying these permutations. Fine? So now we'll just see an example. We'll just see simple examples how the permutation is going to work with. Example. Let's take the first example. I'm just going to have a word called as flower. So F-L-O-W-E-R. So simply taking it as A-B-E-C, A-B-B, which is dummy characters. Let me take a real-time word or real example called as flower. Now in this given flower as a question, now how many ways you can pick? You can pick 4 characters, and in how many ways you can arrange. In the given string, you are going to pick 4 characters or 4 alphabets and tell me in how many ways you are going to do. That is, I am saying you need to pick 4 out of this. That means now this becomes R. The total number of characters in this becomes n. Hence n equals 6. Hence I am just going to apply this to this form, that is Pn comma R. So which is going to be P 6 comma 4, which is equivalent to R factorial divided by 6 minus 4 factorial. So which is going to stay at, so 6 factorial divided by 2 factorial. Fine? And I think you can solve this, but let me just simplify this. So 6 into 5 into 4 into 3, 4 into 3 into 2 factorial divided by 2 factorial. So this 2 factorial gets cancelled, and please solve this, and you can find what the value is going to be, what is 6 into 5 into 4 into 3 is going to be. So if I am not wrong, I need to end this at 360. It ends this at 360 ways. So this is how simply I am going to solve this. Fine. So let me just take second example. So which I am going to take the cat as S-U-C-E-S-S, success. Now just try to apply this now. And which form you are going to apply? Because observe here, all the characters are distinct and different. Now all the characters are distinct, but there are few which is identical. Fine. So now to solve this, I am going to say, I need to, when I am going to find identical, so in that case, I am just going to say R is going to be equivalent to N, which is 1, 2, 3, 4, 5, 6, 7. Fine. So in this question, I am asking you to pick all the N objects. Hence, R is going to be equivalent to N. So which is going to be 7. That is, N is 7. If N is 7, R also wants to be 7, because I am saying you need to pick all the N objects. Fine. So now in that case, now if I am going to apply this, I may end up with the wrong solution because of identical characters. Now for that, I am going to use the general form of this, and the general form is going to point it. So P of N comma R equals N factorial. If there would have been, for example, for this case, for this flower, if I would have said R equals N, in that case, I would have just used N factorial. This would have been worked for me. Just 6 factorial would have been worked for me. But in this problem, when I'm going to have R equals N and N equals 7, because of identicalness, I need to think about the general form. Hence, I am going to say this as 7 factorial, because the value of N is 7. I need to divide this by frequency. Just check the frequency. Now, I am going to have S. So, S is going to be 1, 2 and 3. There are 3 S. And U, I am going to have 1. and C I am going to have 2, and E I am going to have 1. And so 3 plus 1, 4, 4 plus 2, 6, 6 plus 1, 7. So in total there are 7 characters. Fine. So now for that case I am going to have 3 factorial here multiplied with 1 factorial multiplied with 2 factorial multiplied with 1 factorial here. Fine. So I need not solve this entirely. I think you can just compute and tell me what is P and comma R is going to be. So this is how exactly I am going to look into the permutation. So what form I am going to use when N and R are different, what form I am going to use when R and N are same. Being R and N are same, should I use only N factorial, or should I use the general form with N factorial and the frequency of the characters? This is what you need to look into this session. Fine. So let us take another example where I am going to have 4 mathematics books. I am going to have 4 mathematics books or the max books, and I am going to have 5 computer books, and I am going to have 4 Kannada books. Fine. So now I am going to have this many books. So now I need to find how many ways on the given following cases. So in the given following cases, the case A, what I will say is all this kind of books should be together. That is, if I say max book, that is, if I am going to say M1, M2, M3, M4, C1, C2, C3, C4, C5, K1, K2, K3 and K4. Now all these books needs to be together. That is what the first case is. If all the books needs to be together, in how many ways you can make the arrangement? Just observe this. Just observe this block now. So if I just observe this block, in how many ways I can arrange this? I need to pick all the objects, and the books are not identical now. The value of N and R are same here in this case. Hence I need to pick all the 4 books from the method and keep it together always. But I can arrange. The first book M1, M2, M3, M4. Next M2, M1, M3, M4. I can just keep on arranging this. In that term, what it should be? It is going to be N factorial. The value of N is 4, and this will stay at 4 factorial. This will stay at 4 factorial. So now once I am going to have 4 factorial, similarly now I can apply this as 5 factorial. This is the number of ways where I can arrange the books, and this is going to be again 4 factorials. Hence in the first case, this is going to be 4 factorial, and all these things should be along. The task 1, task 2, task 3 should be done. Hence I am going to use the product rule. 4 factorial into 5 factorial into 4 factorial. This is done. And my solution is not yet complete. The solution is not yet complete because now I have done the internal arrangement. The internal element of this is done. Internal of this is done. And internal of this is done, and I have told you how many ways. But now just imagine this as complete one set, because this needs to be as one block of books, and this as the second set, the second block of books, and this as the next set. I am going to have next block of books. Now can I arrange this? First mathematics, then computer block, then Kannada block. In the other way, I am going to have computer block, mathematics block and kind of block. I can just arrange these blocks also. Even this also should be included. This also should be included. Hence, in how many ways? There's how many blocks here? 1, 2, and 3. No identical. Hence, I am going to have 3 here. Hence, I am going to multiply this with 3 factorial. So now this is the first case where I am going to keep all the books as one single block. And this is the solution. So solve this and find what the value is going to be. Now for B. Now in the case B. So in the case B, what exactly I want? Only the max book should be together. All other books I can arrange the way it wants, the way I want. Fine. In that case, I cannot make this as a block. I cannot make this as a block now, because now this need not be together. Only the max books is supposed to be together. This is the condition what I am going to put right now. In that case, I am going to now consider this as one whole book. This entire block is going to be one book at this instant for me. And whereas these books need not be together, hence one book, 2, 3, 4, 5, 6, 7, 8, 9, 10. In total, there are 10 books. And how many arrangement you can make? It is going to be 10 factorial. I am going to have 10 factorial. Again, out of this books, this max book, which I had considered as one single book or one single block, internally I can arrange this M1, M2, M3, M4, so on. Hence, again I am going to end with 4 factorial. This I am going to end with 4 factorial. So this is how I am going to look into the problem, and I am going to see how I am going to solve this using permutations. In the next session, I am going to give few more examples on permutation, and I will get into the combination. But before that, so please give a try on this problem and make sure you get familiar with permutation. When should I use the general form with identicalness, or when should I use the actual form of permutation? What is the form I am going to use when n is equivalent to r, and what I am going to use when the r equals 1. So this is what you need to learn in this session. Thank you.